robotic, unmute yourself and tell me, because I can't hear it. Like, I can't hear it until I go back and try to listen to it, and then it's all garbled. All I have to do is restart a Google Meet. It's just something wrong in the connection. I see Veronica, Declan, Veronica. All right. So also keep in mind that your mole tunes are a test grade, and they are also due tomorrow if you have not already submitted them digitally. By AHA, come back quickly. Okay, so is there anybody else that did not pick this up, even though they've been sitting up here this whole time? You do a paper copy of what we were doing. Everybody picked it up? Luke, how about you? Since you're on your phone and don't have your Chromebook out, you need a paper copy. Anybody else need a paper copy? Or we all have Sebastian, what about you? You need to propose a policy. This stuff is wasted. It might take a few work days of you going through and me basically walking you through them and showing you what you're doing wrong, which is why we had one Tuesday, and why we're going to have another one tomorrow and another one next Tuesday for percent composition. But you have to show me how you're working through them for me to figure out what it is that your misconception is. Let me solve. I don't think I have any typos on this one. I actually went through real quick. Even though I was displaced out of my room, I real quick ran through it. I didn't see anything that was wrong. Let me make my thing big. Freeze. All right. We have 3 things that we can convert between so far. Okay. 2 of them include the word mole. Okay, so I'm going to say 1 mole. I don't know what it is. It's just something. Obviously, it's not going to be the letter X. It's just something. If you're starting in moles, you have 2 things you can change into. What are they? One was from Monday and one was from yesterday. So, okay, particles. Okay, so that was yesterday's. That was Avogadro's number, which is 6.02 times 10, which I'm going to write in E, 23rd particles. And then for Monday, when we were using the periodic table, what are you changing it into? Grams. Now, I can't put, I'm just going to put a number sign here. You guys call it a hashtag, because you have to use the periodic table for this. I'm going to put PT, parentheses. Now, yesterday, the part that confused you guys was sometimes you can go directly from moles to atoms if it's an element, but the other 2 cases you can't. Because if you have a compound, so this is formula unit for a molecule. Let's do this. How do you go to atoms? How do you figure out how many atoms are in a compound? Like, how many oxygens are in oxygen gas? 32. 2. How many total atoms are in water? Total atoms are in water. 3. Now, how many oxygens are in water? 1. So the reason why I can't put a number here for the atom is because you have to count them up. You have to pay attention to the question. Sometimes it's asking for the total number of atoms. Sometimes it's asking for a specific element in the compound. So if I ask how many hydrogen atoms were in water, then there's 2 atoms of hydrogen in 1 molecule of water. That's the part that confused you. You have to take your time. If you need to write out your conversion factors, the paper yesterday, how I put that GOESS, that gave you plenty of room if you needed to actually identify all of your conversions. And some of you write big anyways. You make sure that I give you enough room to be able to work the problem. All right, so the 3 conversion factors, we can go between moles and grams using the periodic table. The mole gets a 1. You have to use the periodic table to get the number for the gram. You can go between moles and representative particles, where the mole gets a 1, and then the particle gets Avogadro's number. Or you can go between a compound and how many atoms are inside the compound by looking at the formula for the compound itself. So I can't tell you specifically what these two values are because for this one, you yank them off the periodic table. This one, you look at the subscripts and formula. We're doing the same thing that we did yesterday, but we're going to bring in the grams. So the answer essentially for the opener, especially for those of you that are online, 1 mole of a substance, that substance is X, okay, it could be any kind of substances, is equal to Avogadro's number worth of particles, which could be atoms, formula units, or molecules. You could go between compounds and their individual atoms by looking at the formula of the compound and their subscripts. Or you could go from a mole of a substance, whatever the heck it is, to its grams, but you have to pull that information off the periodic table, which is what PT is short for. And I don't know if I printed this out or not. I think I did. Did 86A, 86A. Printed the same one out twice, didn't I? Oh, I didn't turn it. So normally, if you're trying to change between different things, if it's more than a one step, the thing that lets them link up is the mole, but that's not always the case. In this case, it's a particle. In this case, it's a mole. It's what lets you take a bunch of one-step conversions and it just lets you stick them together. It's the hardest part, and yes, this class is going to be hard for the rest of the year. It is math the rest of the year. Once you understand, okay, I start with this, I have no choice but to change it into this thing. Okay, I'm going to do that. Then once I'm in that new substance, I have no choice but to change it into this thing, and you keep linking them up diagonally, these work themselves. I promise you, they work themselves. They're foolproof if you understand the process. And you know how to use your calculator the right way. We're going to work through the first problem. I am starting with 1.625E22. You're more than welcome to write the number of the letter E. That's what I do instead of times 10 in a superscript. Of sodium chloride formula units, we want to know how many grams of salt that essentially is. So I see the word gram. I'm going to need to calculate its molar mass from the periodic table. That is the only time you use the periodic table right now, is to when you see grams. If you don't see grams, like yesterday's paper, you don't need to use a periodic table. I'm starting in formula units, which is a particle. In fact, that's my starting thing. If I'm starting as a particle, the only thing I can change it into is a mole. I have no choice unless it's asking me to change it to an atom, which is probably not. So I'm starting with 1.625 E22 formula units of salt. I'm going to put that over 1. What are you going to do with the formula units of salt? You're going to bring it down. I don't care what this unit is. You immediately drop it down 1 diagonally. If, and I know they can't see me pointing, if you are in formula units, the only thing you can change it into is moles. If you're in grams, the only thing you can change it into is moles. We haven't done liters, but when we do, if you're in liters, the only thing you can change it into is moles, where the mole gets a 1. Okay, so I'm starting in formula units. We just said the only thing I can change it into is moles. Once again, I know those of you that are online can't see me pointing. If I'm in formula units, knowing this conversion factor, the only thing I can change it into moles. I can't, there's no formula unit over here. I can't use that one yet. Now I'm not where I want to be. So since I'm not there yet, where is the moles of salt going to go? Down. Okay, so now I'm going to go and look at my conversion factors, which I already just gave them to you. If you're in moles, do you have a way to get the grams? Yes. How did I get 58.44? Where did I pull that from? That's not up there in the problem. The mass. from the periodic table, where sodium, y'all, I have to look too. Sodium is 22.99 and chlorine is 35.45. There's one of each. And when I add them, I get 58.44 grams. Most of you could do the Mondays when we were just going between these. Most of you did those just fine. When I asked you to do the extra step where your brain decided that it didn't want to compute anything anymore. And now I have a way to successfully get from formula units, so from formula units to moles to grams, and I'm going to get my numbers from my conversion factors above this stoichiometry cross. I have to use the one that goes moles and formula units. So what does a mole get? 1. Avogadro's goes to the particle, in this case is a formula unit. And now I have to look at the other conversion factor, which goes between moles and grams. What does the mole get now? It still gets a 1. And what did I calculate for grams? 58.44. I was always taught you double check, you cross stuff out to make sure that everything has canceled except for that top right hand block. So once again, that those are backwards. Let me fix those. Those are backwards. You go here. I said they kicked me out of my room. So what I wanted to do to fix this, you went there. 1, okay. Even though you guys just saw the answer. Stop. Present. Let me get back to where I was. So once again, this is where I got my numbers from. And I don't, like I said, I was always taught to cross out the things that are duplicated top and bottom and to cross out the ones. I was also taught to reduce, but I'm not trying to confuse you. So we're not going to reduce any numbers. We're just going to throw everything in the calculator. You do not need to multiply or divide by 1. So here's the hard part. How do you put this in the calculator? Because you need a scientific calculator, you need that E function. Whether it be irregular, which we've learned, Jimmy, yours didn't have that E. Or if it does, I don't know where it's listed on your calculator. But you're going to put the thing in on the top first, times each other. So 1.625. You're going to use that EE function, which, let me make sure they understand what I'm doing here. I do not like using this. If I make my camera active, this is going to really mess me up because I don't. Okay, so for those of you that are remote, in your calculator, you can sort of move my thing. So regular calculator, oh, my phone's upside down. Regular calculator, turn it to the side. If you have an iPhone, your EE function is right here, capital E, and you're just going to punch in 1.625. And once you punch it, it's backwards on my screen. This is really disorienting. Once you push in the coefficient, you're going to push that EE function. And then you're going to push 22 times 58.44. And then you only have one thing on the denominator, so you don't need to use parentheses if you're using the E function. That's why I'm telling you to use the E function. You're going to do divided by 6.02. And then you're going to push that EE button again. And the 23rd. And you're going to hit enter. And it gives you this huge number in which we're going to round to how many places total? How many numbers total? 1.625 has how many numbers in it? 4. Has 4. 1.625 total places, not behind the decimal, total places. Now let me turn my camera. It is. It's very disorienting because what I see is a mirror image. I know y'all don't see it that way, but I do, and it bothers the snot out of me. Okay, so that means this huge number in the calculator, which I get 1.57749169435, blah, 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 blah. I'm going to round it to have 4 values total. 1.577, the 4 cannot round the 7 up, and now I'm successfully in grams of salt. I cannot stress enough that figure out what you're starting with and what is your only option to change it into, and do that step. Once you're in that new substance, now what is your only option to change it into, and do that step. You're linking them up diagonally. If you're not in the right unit, drop it and convert. If that's not the right unit, drop it and convert. I don't make my students memorize constants. You do have to be able to calculate masses. But like I said, most of you seem to be able to do that no problem, especially since we had that workday, because trust me, I know that the workdays help, and we have another one all period tomorrow. Next one. How many oxygen atoms are in 1.25 grams of sulfur trioxide? Okay, so, well, we have to figure out, hold on. We have atoms, and I gave you the sulfur trioxide as SO3. I do know that I'm going to need, you said how many atoms of oxygen were in sulfur trioxide? 3. I know I'm going to need that, okay? But I also see grams, right? So that means, do I have to calculate the SO3's mass also? Yes. And in order to go from a mole of this to a molecule, I'm also going to need Avogadro's number, which is why this is a 1, 2, 3-step conversion problem. We're still gonna start with something, and we're gonna put it over 1. So if I didn't put my arrows in the wrong place on this one. I know you guys are, anyway, I'm just gonna freeze it because I need to check online, because I know you're writing and you cannot listen and write at the same time. No, you can't. Or at least not comprehend, not retain. So. Okay, yeah, Reagan, we're, like I said, we're sort of reinforcing, but we're bringing in the gram today from yesterday's. Yesterday's had answers on it. There was one, I believe, that was incorrect. I'll double check it and make sure that it's not the only one when I gave you the answer. The one from today doesn't have the answers on it. If I feel really nice, I might put up a screen that has some of the answers on it tomorrow while you guys are working them. But that's what tomorrow for, is making sure that you're following along with this process. All right, now that we have all of this stuff in here so far, we have our 3 conversion factors, and I put in what I start with. What is the very next thing that you should do automatically? Bring down the grams of the sulfur trioxide. And now you're going to look up at your conversion factors, and you have to find the one that has grams of sulfur trioxide in it. It's this one. And if you're in grams of SO3, the only thing you can change it into is what? Moles. Moles. So that's why I have to do that part next. I always do numbers last. I always do units first. Okay, I'm not at oxygen atoms yet. So what should you do next by reflex? Bring the moles down. Now, I already used the one on the top right. So of the 2 that are left, which one has a mole in it? No. The Avogadro's number one. Okay, so I've already used this one. So the one that has moles left is this guy. And the only thing I can change it into, that's short for molecule. That is how I abbreviate molecule. And you'll end up using Avogadro's number there when we end up putting numbers in. I always do that last. I'm still not at oxygen atoms. So what do you have to do next? Drop the unit. Go up and look at your conversion factors. Do you have a way to get to oxygen atoms from the molecule? Yes, this one. That there are 3 oxygens in 1 molecule of sulfur trioxide. Oops, I didn't mean to animate that twice. I think I pushed the back button actually. It is so hard for me to express how important it is to not memorize these. I will give you Avogadro's number. I probably will give you formulas in most cases on the test. I just haven't seen the test yet. You do need to be able to calculate masses, and you do need to be able to identify how many atoms are in a compound by looking at their subscripts. And now we're going to fill everything in. First section that doesn't have numbers. What does a mole get? 1. That's where it's coming from. I know these arrows are about to make my screen really messy, but I'm going to animate them back out. What does the gram get from that same conversion factor? It's 80.07. If you need to use different colors and draw arrows or circles or highlight or write in different colored ink, do it. I do still suggest pencil. And now the second one, this little part, between moles and molecules. What does the mole get? Still gets a 1. What does the molecule get?
6.8.
Avogadro's number. Yeah, I'm done with that conversion factor. Now the last conversion factor that I haven't put numbers down for. Who gets the 1 now? Molecule does. And what goes with the atom?
3.
3. I know these are a bunch of arrows. I'm about to make them all go away, but I'm hoping that they help you see where the numbers come from. There's one more that we're going to do too. And then, yes, I know you guys have questions. And I need to double check because if I'm not mistaken, my answer that I gave you on, I'm going to recalculate them all. I want to say it's number 13. I'm going to double check it. I don't think I gave you the right answer on there. So I'm going to re-crunch them all real quick and make sure that that's the only mistake. I don't always put answers on my phone. I'm going to make all these arrows go away. So gram of sulfur trioxide goes away. And moles of sulfur trioxide goes away. And then molecules of sulfur trioxide goes away. I successfully have changed unit-wise into the atom of oxygen, so that's a good thing. I'm going to cancel out my 1s. Now it's a matter of putting it into the calculator the right way. I'm going to double check and make sure that I did do this. So if you are trying to use the times 10 in the caret, stop. 23 times 3, all divided by, now I don't need to divide with parentheses because I'm only dividing by one thing. Okay, good. I get 2.819408 and a whole bunch of other numbers times 10 to the 24th. How many numbers should be in my answer? 3. So 2.81, but the 9 is enough to round the 1 up to a 2. And then it'll be times 10 to the 24th oxygen atoms. Or atoms of oxygen. I don't care which way you put it. Now, converting units can be applied besides this class. I've done it before in real life. And people were like, I don't know how to convert between a size of a picture frame and metric to standard. And I was like, let me do it for you. And they were like, how did you do that? And I was like, it's chemistry. This is not moles and grams, it was millimeters and inches. They seriously couldn't figure it out. And I was like, wow, all it is converting out units. Okay, before I move on to the last sample problem, other questions on this one? Okay, one more. You are starting with 3.4 times 10 to the fourth atoms of iron in iron 3 oxide. How many grams of iron 3 oxide do you have if you have that many atoms of iron? Now, I can't go from atoms to moles because I'm talking about iron separately from iron 3 oxide. So you have to build the formula for iron 3 oxide. Fe is plus 3 and O is minus 2. It is Fe2O3. I have to calculate the mass of that compound. And I have to know that there are 2 iron atoms in a formula unit of iron 3 oxide. Y'all, this is like I said, when we started this semester, that's why we went back over building formulas. If you cannot get this right, you can't get that right, you can't get that right. Let alone that the equation wouldn't be balanced right. And when you learn how to do a mole ratio, you can't do that part right. I'm so sorry, but this is a very cumulative class. And the stuff that we learned last semester in the second 6 weeks, doesn't go away. So tell me what you're starting with. What goes on the very left-hand side? What goes over 1? 3.4, E24 of the iron atoms. And by all means, do a capital E. Obviously, that's not what I want it to be in. So what's the first thing you should do? You're still ready. No way. Check on. Man, that stuff that they spray is making my eyes burn. Okay, I don't see anybody else. I don't see anything else in the chat. Let me get in person real quick. Davey, Nick, Tiffany, Lucas, Bastion, Clayton, Clayton, Robert. Alexis. Okay, you all ready? I'll pause enough so that we're all caught up and you can follow along. Once you put your starting substance over 1, what should be the next thing you do by reflex? Drop the unit, not the number. The unit is going to be atoms of iron or iron atoms. Like I said, I don't care if you put the Fe before or after, it doesn't matter. But then you're going to take a look at your 3 conversion factors, and you're going to find the one that has the iron atoms in it, which is this one up here. And the only thing you can change it into is what? Formula units, or FU, which it is what it is. Every chemist ever abbreviates it that way. Now you're not at what you want to be. You want to be in grams, but we're not there yet. So once I'm in formula units, what do you have to do next? The next step. Well, you're going to bring the formula unit down first. But what are you going to change it into? What are you forced to change it into by our conversion factors? Moles. Once again, I'm still not at grams. I'm going to bring down the moles of the rust, which is the common term for that compound. Once I'm in moles of rust, I can go to grams of rust for iron 3 oxide. It's a technical term. I'm going to have about 10 minutes for me to come through and help you. These two, you can't see me pointing, these two, this conversion factor between atoms and formula units is this one. Who gets the 1? Formula unit does. Who gets the 2? The atom does. Now this one, you got to find the conversion between moles and formula units, which is this guy. What does the mole get? 1. And what does the formula or the particle? What does the formula unit get? Avogadro's number. I will make all the arrows go away. I know this makes it very, very messy. And then my last one that I don't have any arrows coming from. Well, who gets the 1 now? Still the mole. And what does the gram get? $159.70. Once again, the way that I figured that out was 2 times iron's mass, which is 55.85, plus 3 times 16. I do know oxygen off the top of my head just because we use it so much. Multiply them out and added them up. I'm going to make all my arrows go away. And we're going to cross out. So the atoms for top and bottom, they divide out. My formula units for top and bottom, they divide out or cancel out, whatever phrase it is that your math teachers have taught you. My moles are top and bottom, they divide out or cancel out. And I do not need to multiply or divide by 1. Now, if I rewrite this on the board, which I know is sort of unfair to those of you that are remote, but I'm going to say it out loud, I'm going to clean it up. And what I'm left with on the top is 3.4 E24 times 159.70. And my unit, which is left, which is grams of rust. And then on the bottom, I have 2 times Avogadro's number. If you are putting this in the calculator all at once, you must use parentheses after you hit divided by. So the calculator is not going to do what you want it to do because it is a literal device and it cannot think. Now, most of you have probably been taught to go ahead and put parentheses around the numerator too. You really don't have to, but there's nothing wrong with doing it. So go ahead and see if you can get the right thing in the calculator. This does you no good if you can't mash the buttons the right way. It's just, it doesn't. So I would do, and I don't use parentheses in the numerator because I know better. So 3.4 EE24 times 159.70 divided by, you must open parentheses, 2 times 6.02 EE23, close parentheses, and then hit the enter button. And I'm going to round what I see to 2 significant digits. So I get 450 grams of rust. That 9 isn't going to make it round up to a 1, because if you rounded it to 451, that has 3 6 in it. The 0 does not count. And like I said, the one from Monday, which some of you have finished, I just haven't graded because they haven't all been turned in yet. That was your only problem was, well, my calculator is not exactly what you say because I rounded them. Now, let me check. Let me turn the light on. Let me check this one because I'm pretty sure we're not going to fix this one. Calculator. I'm going to unfreeze this or stop the recording. Now,